Now that we know about gravitation, let's have a look at this number g. Now, when we first introduced g in mechanics, lots of people like to ask me questions about it, and so hopefully this is where some of those questions are answered today. G, gravitational field strength, sometimes called acceleration due to gravity, 9.81. Where does that number come from? Why gravitational field strength? So to start off with, from this point on in the course, I don't want you to call G acceleration due to gravity anymore. Cast that aside. G is the gravitational field strength. G is the gravitational field strength. Gravitational field strength is defined as this: the force per unit mass at a point in the gravitational field. Think about that for a second. The force per unit mass at a point in a gravitational field. Let's have a look at this mathematically. Let's take that equation for force from last lesson. F equals minus g mm over r squared. I know there's a minus there. Ugh. If we divide that by mass, and that is the mass of the object, say me, this comes out as gm divided by r squared, with the minus again. Gravitational field strength is force per unit mass, so this number g, gravitational field strength, is represented by this equation, minus gm over r squared. But Rob, that has a mass in it. Big M is a mass. Yeah, it's the mass of the object that's producing the field. So big M, that's the Earth. You know, little m would be me, or my spaceship, or a satellite, or a car, or whatever. The mass of the Earth is required in order to generate the field. And we can work out the field strength due to the Earth's field using this equation. G equals gravitational constant, mass of the Earth, divided by r squared. That's the distance from where? The centre of mass of the Earth. Yeah, remember that. Came from the law of gravitation. So that's G, that's field strength. In terms of plugging in the numbers, remember the gravitational constant, 6.67 times 10 to minus 11. M is the mass of the body producing the field. So maybe it'll be the Earth or the Sun. It's always it's a capital M. Capital letters are always big numbers, except for G, okay. And R from the centre of mass. A common mistake is that people go from the surface. If I went from the surface here, that would mean that my R, when I'm stood on the ground, was 0, and the gravitational field strength would be infinity, and that doesn't make any sense. It needs to be R as in the radius of the Earth. And you can verify this, just have a go right now. If the radius of the Earth is 6,400 kilometres, and the mass of the Earth is given there as well, you can put these numbers in and just verify that the gravitational field strength is 9.81. Give it a go. It's handy, right? We can look at a field in terms of its field strength, and it doesn't matter what mass the object that's in that field, it will always experience the same field strength. That is what this quantity is for. So what do you need to know about G? What else? Well, gravitational field strength is force per unit mass at a point in the field. It's calculated by minus gm over r squared. The minus, again, is just one of the... And you also just need to know how that looks. And this is where I can answer the question that people say, well, what happens to gravitational field strength inside the Earth? What happens to the gravitational field strength as I go towards the centre of mass? And this handy little graph here, which you need to learn, shows how G varies with radius from 0 to the radius of the Earth and then beyond. So have a look at it. Between the centre of the Earth and its radius, we get a straight line relationship. It increases linearly inside the Earth. At the radius, the gravitational field strength is a maximum because we are really close to all of that mass, and you know for Earth at the very least its maximum is 9.81. You can work it out for any other planet, obviously, just put the numbers in. But 9.81 on the Earth's surface, that is the peak of this graph. And then obviously it's a 1 over r squared relationship, so it's a bit like a 1 over r but steeper at the start and end. It doesn't ever go to 0, that's the point with gravity, it just gets smaller and smaller and smaller the further you go away, but it never reaches 0. It's a 1 over r squared curve beyond there. You have to recognise that as radius grows, g decreases quite significantly. And that's all that graph tells you, it's field strength against distance. That is literally all there is to say about g. Field strength is something that relates to all forces and all fields. We can get an electric field strength. All of the forces have this property, and if we learn about it properly with gravitation, it'll save us spending quite so much time when we cover it in electric fields later. G features in things like gravitational potential energy, so it's important to know, and it's relevant when we're looking at planetary motion in the next few books as well. So field strength, G, is the force per unit mass at a given point in a gravitational field. Make sure that you get to grips with this very, very easy formula and this very, very easy graph. Try the end-of-topic questions when you get a chance. I don't think you'll have any problems, but if you do, obviously you know what to do.